Since everyone makes fun of how I start all my videos, I'm just going to get started and not say hello. But this is our last note video for this unit. We're going to be talking about comparing solids. So I will be able to compare solids and their dimensions to create ratios. So ratios is going to be the big topic here. Before we get into ratios, we're going to do a problem where we work backwards. So the volume of a cube is 125 cubic inches. What is the surface area? So we need to work backwards with our volume to find the dimensions, and then we'll be able to plug that in to find the surface area. So first, my volume formula for a cube is just length times width times height. And since it's a cube, that means each face is a square. So the length equals the width, which equals. So I can just write that my volume, 125, equals length times width times height. Since we said that all of those are going to be equal, then I can just take the cube root of this, since it's going to be equal to one variable cubed. So I could write 125 equals x cubed. So to do the cube root, it's kind of like the square root, but you're going to have to click that math button on your calculator. We'll talk about how to do that in class. So the cube root is going to be 5 equals x. So my volume is 125, but my length, which is also the width, which is also the height, is 5 here. Now that I have that, I just need to write down my surface area formula. So 2 length times width plus 2 length times height plus 2 width times height. Now I just plug in my variables and solve. And since all of them are 5, this is going to be super easy. I can just plug in 5 for all of these variables. So then once I have this written down, I can type that into my calculator. I get that the surface area is equal to 50 plus 50 plus 50, which is 150 inches squared. Alright, so you guys have a problem here for you to try just like that. It's got a sphere instead of a cube, but a cube and a sphere are going to be the two solids that you'll see where you'll work backwards from one to find the other. Let's go ahead and shift our papers down and try the ratios now that I mentioned earlier. So we're going to be able to compare lengths to areas to volumes of two different solids, even if we don't know all of the measurements. So if we look at these two squares here, my ratio from this side to this side is just 2 to 3. It's in its simplest form, and that's going to be the ratio A to B. Well, now if I look at the surface areas of these two cubes, so just looking at the areas, well, I know that area is going to be 2 times 2. Area over here is going to be 3 times 3. So I can write that as 2 squared and 3 squared. And I can simplify that to 4 to 9. So our ratio of the areas is going to be a squared to b squared. And then since we square for areas, if you haven't guessed it, we're going to cube for volumes, since volume is talking about 3 dimensions and the inside of a shape. So it would be 2 cubed to 3 cubed. And when you type those in your calculator, you get 8 to 27. So now we're going to look at problems where you'll be given one of these ratios and asked to find another one. So slide your paper down, and we are going to look at this bottom left one here. I have that the volumes of two pyramids are in a ratio of 4 to 32. What is the ratio of their heights? So my given ratio is volume. It's 4 to 32, and my volume is cubed, so it's a cubed to b cubed. Well, the first thing I want to do, I mentioned having the simplest form up here for the ratio. 4 to 32, I want to think about if those are in the simplest form, and if I think about factors for each number, they're not in the simplest form, because I can divide 4 by 4 gives me 1, and 32 divided by 4 gives me 8. So I can change 4 to 32 to 1 to 8. So that is in its simplest form. So now 1 to 8 is a cubed to b cubed. Simplifying it first is going to make it easier for you to solve, and it's going to guarantee that you get the right answer. So you always want to check that your given ratio is in simplest form. All right, now we want to solve for our ratio of A to B. So no matter whether you're given length, surface area, or volume for your ratios, you always want to go back to your length ratio, because if we have A, we can easily find A squared and A cubed. And if we have B, we can easily find B squared and B cubed. So what I want to do down here is solve for A and B. Well, I know that 1 is going to be A cubed, so I can just write an equation here that 1 needs to equal A cubed, and 8 equals B cubed. So again, since I've got cubed here, I need to do my cube root. I'm not square rooting. I need to cube root everything. So the cube root of 1 is 1, so 1 equals A. And the cube root of 8 is 2. Cube root of B cubed is B, so 2 equals B. So that means my new ratio A to B is just 1 to 2. Lastly, I'm asked for the ratio of their heights. Well, height is going to be a length. So length might not always literally be length. It could be height, width, length, side, anything that is just one part of the shape. So A to B is what I'm looking for, and that's what I found. So I've got it, 1 to 2. All right, go ahead, flip your paper over. We're going to try a few more of these. If we look at this top left one, it gives us the ratio of the surface areas of 50 to 98. But what is the ratio of the volumes? So this is one where we're going to have to do an extra step. If I'm given 50 to 98, and that's the ratio of the surface areas, then I know that that's going to be equal to A squared, B squared. That's the ratio that I'm given. First, I need to see if this ratio is in simplest form, and it is not in simplest form. So we need to simplify this. Thinking about 50 and 98, I know that both are divisible by 2. So 50 divided by 2 gives me 25, and 98 divided by 2 gives me 49. So my simplest form for my ratio is 25 to 49 as A squared to B squared. So now that I've got it in simplest form, I can solve for A and B. So I have that 25 equals A squared and 49 equals B squared. So if we take the square root of each side, since it's just squared here, we don't need a cube root, we're just square rooting. So the square root of 25 is 5 equals A, and the square root of 49 is 7 equals B. So now I have that my ratio of A to B is 5 to 7. But that's not my final answer, because the ratio of the volumes is what I'm looking for. So if I have A to B, well, volumes, so volume is going to be A cubed to B cubed. So I need to use my A and my B, 5 cubed to 7 cubed. And if I type that in my calculator, I get 125 to 343. So this over here for volume is my final answer. All right, I'm going to walk you guys through one more problem, and then we will call it a day for this video. So scroll your paper down. This is another way you might see the ratios when you are comparing two shapes, but kind of in the context of a word problem. So here we have a cylindrical paper towel with a height of 7 and a radius of 2. So I'm going to jump down here. That first paper towel roll, the height is 7 and the radius is 2. If the height and radius are doubled on a second paper towel roll, what will be the ratio of the volumes from the original towel roll to the new paper towel roll? Well, if it's doubled, that means I'm going to multiply by 2, right? Just doubling it. So I'm going to double both the height and the radius. So 7 times 2 gives me a new height of 14, and 2 times 2 gives me a new radius of 4. So my given ratio, since I'm comparing one paper towel roll to another paper towel roll, I don't want to pick these numbers. I want to pick one number from each paper towel roll. So you can do 7 and 14 or 2 and 4. I am just going to pick 7 and 14 because those are the first ones there. So 7 to 14 is my A to B because they are the heights, so it's just A to B. because that's considered a length. 7 to 14, is it in simplest form? No, it is not, because both are divisible by 7. So 7 divided and 14 divided by 7 gives me 2. So my new ratio is 1 to 2 for A to B. And you'll find that if you did 2 to 4, it also would have simplified to 1 to 2. So either 2 that you had picked would have given you the same ratio. All right, solve for A and B. Well, luckily that's what I was given. So A to B is 1 to 2. Now I need my new ratio for volumes, because it's asking for the ratio of the volumes. So volume is A cubed to B cubed. So 1 cubed to 2 cubed is what I need to figure out. And if I type that in my calculator, I'm going to get 1 to 8 as my new ratio. All right, great job, guys. Thank you for watching, and you are officially done with your last unit of geometry. So congratulations.